Okay, my name is Steve Olsson, and I'm here to talk about some of the file server features, setting up a file and print server. I'm talking about the storage pieces. This is a 4-track session. There's 4 presentations all in all. So I have quite a bit of material I want to go through, so I'm just going to dive right in without any formalities. Our biggest feature by far is shadow copies, and although that's kind of a daunting name, shadow copies, it doesn't have to do with old movies. It's actually snapshots. However, the word snapshot's trademarked, so we had to come up with something new, and shadow copies is the best we came up with. This is a volume-based snapshot feature. Around the snapshots, we've added a backup infrastructure, which allows third-party ISVs and ourselves to be much better with respect to backup. We've also added automated system recovery. This allows a much quicker and a much higher fidelity restore when your disk drive in your server goes down and you need to get it back up quickly. And we put a lot of command line scripting tools around some of the storage features. We've had a lot of issues in the past about not being able to script setup of a large number of servers, and so we have scripting put together, which I'll show you a little bit later, so you can to help with deployments of a large number of machines. Additionally, we've added virtual disk service, which is a sister service to Shadow Copy, which allows you to have more visibility within storage boxes so that you can see the LUNs that are there and see how they're created from which spindles. So without further ado, I want to talk about a few basics first. We'll talk about basic and dynamic volumes and how to choose which is the right for you. Basic volumes they now support growing volumes online. This is a complaint that we had in the past, that you can't grow your volumes online when you have basic volumes. We've added a command line tool called DiskPart, which I'm going to demonstrate later, which allows you to grow volumes online. It's also, basic is the best choice for shadow copies, because as you make hardware copies of a disk and you begin to import them, you can import basic volumes back onto the same machine without having the confusion of the dynamic volume database. Dynamic volumes are the ones that support fault-tolerant configurations. So if you want to mirror your boot and system volume, which is a good thing to do on a server that's important, you need to make that a dynamic volume. Dynamic volumes supported growing volumes online in Windows 2000, and we still support that through the UI, and DiskPart also is a command line utility that supports growing dynamic volumes. Supports volume sets, but it's not supported in a cluster configuration for the same reason that the signatures are required in cluster to identify it, and the disk groups have to stick together. Okay, so I'm going to go into shadow copies in a little bit of detail, because it's really important that you understand exactly what we're doing with a shadow copy to help with understanding if you should implement this or not. A shadow copy is a point-in-time copy of a volume or a number of volumes. You could create a point-in-time a copy of the disk, and we have many ways of implementing this. I'll talk about this a little bit later. At the completion of the shadow copy, you get an apparent or an actual new volume that's created as hidden and read-only. The initial intent of this feature was for backup, so that you could take a snapshot of the disk and you could proceed with a backup of the disk. And I'll get into some of the details later on more slides. I don't want to give away too much now. The user or application could continue using the original volume, could continue to move forward, but the snapshot remains a point in time. Our shadow copy infrastructure involves the services and applications so that they know what's happening. In the past, there's quite a few snapshot engines on the market today from third parties. And the one thing that's really missing from these engines is they don't own the file systems, and they don't cooperate with the applications because they're owned by other parties. So in reality, Microsoft's the only one with enough contacts throughout the industry and ownership of the file system that can put together what's considered a consistent snapshot. In other words, the applications know what's happening, and they can pause the writes for that period of time while it's being created. And I'll get into that in more detail later. The scenarios that we're looking for is we wanted to back up open files. With a snapshot, you could do that. The snapshot, the files are no longer open. We want to eliminate the backup window completely. The backup windows are getting to be a problem with the quantity of data that's on servers today. Applications register to be backed up, and they provide information to the backup applications about how to do the backup and where the data is located. It's also another feature that's really nice with shadow copy is data freighting. If you have a hardware plex and you break it, you can move one of the plexes through the SAN and make it appear on another server. And we'll talk about some of the scenarios of data freighting. And there's also, we have a feature added in Shadow Copy Restore, which is going to be covered in the next session. Okay, so the infrastructure that wraps around shadow copies specifically for the intent of backup, but as it turns out, we have there's quite a few uses beyond backup that we plan to exploit and we expect third parties to exploit. So the synchronization across volumes includes the freeze-thaw for trained applications. As applications include a component called writers. The writers are the pieces that run within the process, an application process or a server process, and help gain the consistency. We also include discovery and enumeration of the shadow copies and the applications that are running within the shadow copies. And we understand when pieces have moved within a SAN, if you create a snapshot and move plexes within a SAN, we know that that snapshot that we got, number one, is a snapshot, and we know where it came from. So we track the snapshots that you create within a SAN. We also, it's an open architecture, so we allow IHVs and ISVs to plug in shadow copy engines. I'm going to drag you through this. This is fairly technically detailed, but it's so important to understand the architecture because this is such a major feature. We expect a lot of people to be exploiting this feature. So this is a backup application that I'm going to run you through and explain what the pieces are. We have a requester, that's our fancy term for a backup application, and then we have the VSS interface. This is the volume shadow copy interface. The writers are the pieces that run within the process of the application and services, and the providers are third-party pieces and Microsoft-provided pieces that allow you to control storage. For instance, Microsoft's provider is a software-only provider, and we create the snapshot. This is the question I get in every presentation. How do you get that data copied so fast? We don't copy any data whatsoever. The way we create a snapshot is we look at the original volume, and at the time of creation, we do no copies. We just establish a delta file. Whenever any sectors change beyond that point in time, we pull the old sector data out and put it in the delta file, put the new sector data down, therefore the volume appears to move forward. Now when you access the original volume, it's completely intact and up to date. When you access our dummy volume, the snapshot volume, you're actually accessing the original volume for everything except the changes that have been made. And we keep a map of what has changed, what sectors have changed, and we go to the difference file and pull up the old sector and present that to you instead. So at the time of creation, this only takes a very short period of time, in the order of a couple of seconds, to create this snapshot. So we're not copying the entire disk, we're faking you out with the shadow copy. When you access the shadow copy, you're actually accessing the original volume except for the new changes. Okay? In addition, we have several third parties working in our labs today to provide a shadow copy provider for hardware. Because in hardware, it's really easy to visualize. You have a mirror. At the time that you want to break the mirror, you break it. Now you got an original that continues to move forward, and you got a static one that sits here. So that's very easy to visualize. We support both techniques, and in fact, we support other techniques too. Okay, so that's the basic block diagram. Here's the process. Here's what we go through. The requester goes to the shadow copy interface and queries the writers. This is where he discovers what applications are running on this box that are snapshot aware. SQL, Exchange, services, there's Active Directory, Cert Server, DHCP, WINS. All of these things need to be backed up, and he queries it. He gets back metadata. The metadata is in an XML form, but it's completely abstracted through APIs. So he takes the data and he aggregates the data together to determine what volumes have to be snapshot. Okay? And although it's hard to read here, the volumes say he's decided he has to snapshot the C and the D volumes by looking at the metadata and putting it all together. The metadata contains a wealth of information about the application. Information like, where's the data located? What are the settings for the application? What are the components for the applications? Components are things that need to be backed up together, like a database and a log. They're not very useful individually. You got to make sure you have those two together. And how do I do the backup? And how do I do a restore, should that need ever arise? So the requester then, the backup application, then goes back to the shadow copy interface and says, I'm about ready to do a snapshot. No rush now, but get ready. So the prepare to freeze time is not bounded by time. It gives applications an opportunity to get ready to create a snapshot, because when we create the snapshot, it must happen quickly. Then the requester says, freeze. The writers are all involved. The writers all return, okay, I'm ready. As soon as that happens, the freeze process begins to happen. The providers are notified. The shadows are created, whether it be via hardwareplex or a software volume is created. Everybody's notified, and the volumes are created. This is a very quick process. In fact, if we don't do it within 30 seconds, we just fail the whole process. It's okay for writers and providers to fail. We'll go back and retry. If the writer's in the middle of a 4 gig write, he's going to say, can't do it. That's not going to work right now. Come back later. And that's okay. So once we hit this process, we now have a snapshot set of disks. And they sit out there on their own. The C and the D volumes are sitting there. And right now, they're not attached to anything. Then the requester goes back to the writers and said, I'm finished making the snapshot. How did it go? And everybody answers, that was good, or it was a failure. At that point, if it was successful, the requester has the volumes all to himself, and he can just go take all day to get that data off to tape. They're read-only. The user doesn't have drive letters popping up that are automatically mounted. The requester can surface the volumes if you want. You could surface it with command lines. But essentially, they're read-only, and they're dedicated to this process for the backup. After the completion of the backup, we need to close the loop. So we close the loop to the writers, and we give the writers a list of the things that we successfully hardened onto tape. So the writers now have an opportunity to truncate logs, delete files, whatever they need to do. It's completely open what they can do. But they have a closed loop feedback that says, I was successful in creating this backup. Following that, the requester says, I'm done. Everybody's alerted. The disk can be either reclaimed in terms of a hardware plex, or we can delete the diff area and just go back to the original drive if it was a software. So, that being said, just to wrap up, the process that we have, the difference that this is between a third party, the ability for a third party to do this, and for Microsoft to do it, is we're communicating with all of the applications that are snapshot aware, and we have control of the file system, so we can flush the buffers, synchronize the disks, so when we get a snapshot or a shadow copy, the data is consistent. In theory, you should be able to take those drives, the copy, and boot off of them. Okay? There are some other issues with that, but effectively, the data needs to be completely consistent. Okay, I'm changing subjects now. The next topic I want to talk about is virtual disk service. This service, let me just take a moment to kind of describe what's happening. The snapshot has a very good value with third-party storage arrays because there's an array out there, it sits on a SAN, you have the ability to create a snapshot, move it across the SAN to another machine. You got another machine over there that can do data mining on your SQL server or backup of your Exchange server, all sorts of fancy things. The issue that we faced is that to us in the box, a third-party disk array just looks like a volume. We really can't tell what's in that volume. It's, you know, you got your Compaq or your Dell array and you plugged it in and, wow, you happen to have a 1 terabyte drive. We don't know how that's created. So in order to create the volumes, in order to have a sister service to snapshots, to create the volumes that we're going to break, or just to create the volumes in general without having to use a bunch of third-party tools, causing all sorts of learning and, you know, figure out how third-party tools work, we felt it was important that you could virtualize the storage yet still understand what's underneath. So we need to know which spindles are there, how the disks are put together, how the LUNs are created. And this is the basic intent of VDS. We want to be able to plug in a third-party box, tell it, create a 1 terabyte volume for me. Then I want to look at it and say, how did you do it? You got 15 spindles out there and you put them together in a mirrored set. That's great. I understand that. Now I can go to my snapshot service and say, I understand that volume out there. Now I can break a snapshot. So that's the point of the virtual disk service. The benefits, a common command line for all hardware vendors that participate within our infrastructure. We don't have APIs in this version. It's all command line. We're going to put in APIs so that it's a little more effective tool for data management, storage management type applications. The goals, we wanted to support all the vendor and make it completely neutral. It's just the infrastructure. Vendors can still have third-party add-ons. They can still do their own value add. We wanted to manage the logical volumes and manage the LUNs. This is a block diagram, generally how it looks. The dark yellow are the pieces that Microsoft provides. The light yellow are pieces that can be put in by third parties. But it's very straightforward. We get a basic disk provider, a dynamic disk provider. Veritas has Veritas Volume Manager that can be put in to replace our dynamic disk provider. You have hardware providers. We're working with many storage vendors at this time now so that we can support their hardware when we release. We have command line interfaces. Management applications can plug in, and also the disk management snapping that you already have seen. The features, the VDS Coordinator Service. The service is, as you saw in the block diagram, software provider. This is a little bit redundant from the block diagram. The software provider for basic disks, for dynamic disks, disk part, which I'm going to demonstrate to you at the end of this, for command line and additional commands, disk management, hardware providers for PCI RAID using StorePort, and the disk RAID CLI, which I'm going to go into more detail as we move on. A little bit of redundancy here. The in-the-box providers. This is what we put in the box: the basic dynamic RAID port and our StorePort and 2,000 down revs. And other providers can add on. There's both the ability to add software providers and hardware providers. So if you think you've got a really whiz-bang method of creating mirrors with software disks, we'll support that. We also have some remoting capabilities built into VDS so you can manage it from a single machine. You can go out and run it on remote machines, which is nice if you have a large number of storage servers deployed. Software provider runs wherever the volumes are mounted, and here again, IHVs can snap into it. Okay, so VDS is kind of its early versions within .NET Server. We do have a roadmap for future things. I want to make it clear that this is not VDS of today. This is the future that we're going to add in. We need to put in LUN masking to support multipath configuration. We need to do a little bit more work with a SAN device discovery and remote hardware providers. If you've got a little bit of smarts in your array, you want to do some of the work down there, we're going to do some work. We also have a feature for fabric management. Part of the infrastructure, the three key pieces of the infrastructure are the shadow copy service, the virtual disk service, and another piece which we do not have in the product yet called fabric virtualization service. And effectively, what FVS does is it provides an abstraction to the fabric control boxes, the Brocades or the McData switches, so that any third party has an abstracted set of APIs that they can create volumes to the third-party box. They can create snapshots either internally or in third-party box, and they can control the fabric, which allows rezoning LUNs from one machine to another. We're also working on some two-site geomirroring type of things. Disaster recovery. Okay, I'm changing topics again. We're moving off VDS, going on to disaster recovery. So it's pretty easy to describe a disaster. You lost a disk, you had a fire, whatever. You've lost your machine, catastrophic failure. You want to restore your hardware configuration, your applications, your operating system. ASR will do that. ASR does not restore user data. That needs to be a separate one. What ASR is it is a very big hammer to get your machine back. So the old way in Windows 2000 is the administrator has to go out and buy some new hardware. He's got to install Windows. As you all know, that's a couple-hour process. He has to configure his physical storage because there's no way in Windows 2000 to configure dynamic disks without having the operating system up and running. So he needs to get the operating system up and running, configure his storage so that he can do the restore. He has to install the backup and restore application. He has to install the media drivers. And then he has to recover the operating system through the restore process of his backup application. Then he has to reboot. There's plug-and-play issues. He has to adjust services. DHCP needs attention. DNS is going to need attention. And finally, he restores the user data. So let's talk about the new way, automated system recovery. It's a new in .NET and XP, so you can try it in XP now. The user administrator goes out and has to buy new hardware or fix what he's got. Then he puts in the Windows distribution CD, and he hits F2. He inserts the other media. Since it's a completely open process, third parties have worked to implement our ASR in their backup applications so that he may have to put in a product from another company, and then he restores the data. We shorten the steps quite a bit. Basically, it looks like this. Your server goes down, you need your retail media, you need your backup tape, and you need a floppy. You put it all in, you push F2, and you go have a cup of coffee. Then you come back. Yeah, okay, so your server's down. Maybe you're not having coffee. Maybe you're biting your fingernails. Your server comes back. You have to do your data restore at that point. If your data has actually been lost, in most cases of critical servers, you might have your data on an external box or on another disk. In that case, you may not need to, and the job is done. Okay, the ASR goal is to bring a system that's failed back. That's all. We reconfigure the physical storage and we restore the operating system. That's what the job is. Nothing more. And we also provide mechanism for third parties. In the picture, a couple slides back, there was a second CD. If you're not using NT Backup as your backup application, the second CD would represent the third-party backup restore application. And we have the ability to prompt for that CD during ASR. All of the ASR questions are asked right up front before you move on, and then once you get going, it's a completely hands-off operation. Okay, so let's talk about the exceptions. The hardware really has to be identical. And when I say identical, what does that really mean? You can never get identical hardware. Even if it's the same part number from the same manufacturer, it's not identical. Actually, in reality, we're very flexible. There are some things that catch us. We have trouble going from IDE drives to SCSI drives and vice versa. We have trouble if you have a single processor and you change it to a dual processor. The issues there are the processors. They're so similar. We have trouble. We're putting back all of the same drivers, and we have trouble sometimes with how you may end up with a single processor, the other one idling. But in general, we actually work very well across different machines. We work exceptionally well with video cards and NICs, because the intent is that these are the kind of things that are going to be replaced frequently. So we work very well. Video cards fall back to VGA mode whenever they're not recognized, and NICs just reinstall. You may have to go back and make some adjustments if your hardware is different. You may have to go actually reconfigure your network, because the bindings on the network tie to the network card through plug and play. And so if you change the network card, you may actually have to go back and do the reconfigure the network. That's not really a big deal, because once you just say, that's my network card, it usually just binds onto the new network card and it's done. Video cards, change your resolution and your color depth. It usually takes care of it. Simple as that.
How are we with regards to SCSI cards or private host bus adapters?
Yes. The question is about host bus adapters. You may have to reconfigure them, but generally that works very well. You have to have the same number of disks. You can't decide. If we can hold questions till the end, I'll have an open session. I think it'll be a little more effective. Thank you. You can't decide that you want to do your change in configuration at this point. If you started out with 15 disks on your system that were 10 gig each, you can't change to one disk that's 150 gig and expect this to work. It's restoring back to the spindles that originally were there, to the volumes that were originally there. So if you can't recreate all your volume, backup application is going to get confused and not know where to put the data. So you have to have the same number of spindles, the same number of volumes. However, they can be as big as you want. You can replace your 10 15 gig drives with 10 150 gig drives. That'll work fine. In fact, we'll even extend the volume out for you. So you have to have the same number of disks. The storage capacity of disk has to be at least equal to, and greater is fine. And the disk geometries have to be compatible. If the size is very, very close, there's 10 gig drives that are 10 gig drives, and there's 10 gig drives that are 10.01. So either you have to have, the same geometry on your disk if you're changing a 10 for a 10, or just make it bigger. The ASR state file. We create a floppy. All right, I know. I'm sorry. We have to have a device that's recognized in the BIOS. We're doing a lot of pre-pumping of plug and play to make sure that your bindings come out the same. The ordinals on the plug and play have to match, or things really get messed up. This is the issue that if you're doing a manual system recovery, in other words, you're just doing a restore of the entire system, sometimes your network cards flop because plug and play runs and it doesn't know which one's first and which one's second. So if you had a wide area network and a local area network, the settings could swap. If you end up with the same two cards, it has no way of telling. So on our ASR state file, there's a plug and play CIF on there, and there's an ASR.CIF and an ASR.PNP.CIF are the two files. And those are the steering files for plug and play. If you boot up without that, plug and play is already run. So we have to have a pre-boot environment where we can get some data. And today, that's a floppy. Although I'm going to reverse myself on the next slide. The floppy, you put in the floppy, it gives the steering information. It also has all the information to reconfigure the storage and to look at the versions and to get them in, the machine name and the things you need before you start the restore process is all contained within the floppy. They're very small files. Don't worry about growing out of it. I don't think you can hook enough disks to your system to grow out of the floppy. Okay, ASR and clusters. We support clusters. ASR supports clusters. You have to do each node at a time. If you have a single node fail, then you restore a node that's failed, or you restore a number of nodes that failed. you can get if everything fails, you can do an ASR of the first machine, bring it up as a lone wolf, and then as you do ASR of your additional machines, they just reboot and they come up and they join the cluster. So we have a concept of critical disks specifically for cluster and a couple other scenarios. We will restore all of the storage configuration in ASR, with the exceptions of disks that we know exist but aren't accessible. In the case of shared disk, if you've had one node fail and all the disks have failed over to the other node, we'll recognize that those disks are not critical to the ASR and not configure them. So, in fact, I think we do a pretty good job of supporting the clusters, and we've been working with it for quite a few months. Okay, so what happened to the emergency repair disk? God, I've had this question 1,000 times. The emergency repair disk, a floppy, is too small to contain a registry today. The emergency repair disk had been whittled down to where it's just virtually useless, and so we just got rid of it. There's no longer an emergency repair disk. If you're at a point where you need to use the emergency repair disk, you should be using the repair console, and if that doesn't work, ASR is the right answer. We always format the boot partition. We will not format other volumes with your data on it. The concept here is you're doing this because you've got a serious operating system problem. We're going to format the operating system and restore it. So be aware that when you run ASR, you're going to get your boot system partition formatted. After that, if we determine that your data volumes need formatting, and the way we determine that is disk signature, the same partition, the same size, a partition with the same formatting, we say that's intact. We're not going to touch it. So we're not going to go through and automatically just format every drive array that you have hooked to your box. We're going to try to do it, but we always format the boot partition. Basic and dynamic disks are supported. We'll reconfigure dynamic disks. A major feature for those of you, and we had a lot of issues with our backup ISVs that you couldn't reconfigure dynamic disks for ASR. x86, IE64 platforms, MBR, GPT, EFI disks. You do need a floppy drive. Newer computers will be coming out without a floppy drive. ASR itself is not networkable or remotable. However, we've put in the hooks so a third party can do a network solution. ASR in the box, we don't have any networkable or remotable. Now I get to go back and touch upon something that I think is a really good fusion of a couple of technologies here. It's ASR with RIS. If you have a RIS server set up, the RIS can deliver the ASR image to the server using Pixie Boot. So suddenly all those things I said about you have to have a floppy disappear because the RIS server can deliver the two files. And the RIS server is something, and Pixie Boot is something that actually works in the BIOS prior to any operating system running. So no floppy required. You don't have to push F2. It uses Pixie Boot. It just comes up and runs. We have a white paper that's in preparation now that you can get if you're interested in doing this. It's a very good solution for recovery in an enterprise where you already have a RIS server set up. Okay, command line scripting. We've been focusing a lot on command line scripting for large deployments. So FSUtil is an old utility that's been in the product. It's kind of just a grab bag for all the file system utilities. DiskPart is a new one. DiskPart we've actually ported back to Windows 2000, and it really helps with the configurations for Windows 2000. You can download that off the web. Disk RAID is to support the VDS that I was talking about earlier, and VSS admin is a command line for snapshots. So all of this, there's help in the product. If you know the name, just type FSUtil and you'll get the help files. This is the grab bag, quotas, control the behavior of the file system, manage volumes. It's a good utility. It does an awful lot of stuff, There's good help for it in the product, so I don't really want to dive into it and get into a lot of detail because it's all really in the help file. It's good to know that it's there. Okay, disk part. This, I think, by far is the most important command line just for general storage management. This is the solution that we provided. I'm not going to go through everything, don't worry. This is the solution that we provided for managing storage online, and I'm going to give you a demonstration of that as soon as we're finished with about 2 more slides. It allows you to create volumes, convert volumes, basic, extend volumes, list the volumes, list the disks, just a wide variety of tools. And it's scriptable so that if you're deploying a large number of servers, you can configure the storage via scripts. Disk RAID. This is very similar to disk part. I should have put some more detail on the slide, but it's very similar syntax to disk part. Allows you to control and configure storage within a third-party disk array. So this is the command line I was talking about in VDS that allows you to create partitions and delete the partitions and automatically create different size of partitions with RAID 5 sets, etc. And VSS admin. VSS admin is the command line that we put on the front of shadow copies. So you can create a shadow copy and delete shadow copies. You can list the providers that are installed in the box. You can list the writers. The writers, if you remember from the block diagram, are the components that are running in proc with the applications and the services. And if you have a software provider, you can manage the diff area. So the diff area is the delta area that we're keeping the old sectors in as the snapshot moves forward. Maybe you want to move that from one disk to another. Okay, so let's do a command line demo. Okay. That's better. Got my fish. Okay. So I'm going to start out here. As you notice, I have my nice little FireWire drives because they're really easy to carry around to demo. So I have a couple of disks attached to my laptop here. And so I'm going to start out, as you can see, the disk administrator is running in the background. And I'll just pop that to the front. Got too many mice. Okay, so I have my basic volume, which is the disk that I use every day in my laptop, and then I have these 2 raw disks that have been attached, just attached. So I'm going to run a little script here, I hope, if I get the right keyboard. And I'm going to create a couple of partitions on my new disks, but I really don't want to use the whole disk at this point, so I'm just going to create about 1 gig apiece. And you can see the command or the UI in the background has now updated, and I've created a couple of partitions on those disks. And now, for the fun of it, I forgot what I named my script. And I got to get on the right keyboard. I'm going to format those and throw a little date on them. See that? Okay, so I'll go ahead and I'll format both of those. I made them small so the formatting goes quickly. Did a quick format for you guys. And just to show that I'm not lying, I'm going to copy some data onto it. Okay? So now I'm going to come over here and I'm going to look at my computer. I assigned drive letters to them so we could just pull them up here. This is my new drive E, and I got some pictures of going snowmobiling here. Quite a fun day, a lot more fun than today. Okay? And I've also got F here. It's formatted in TFS. And we had a little snow at the house the other day, so I took some pictures of that. Okay? So I got all my data there. Everything's cool. Now I'm going to come back to the command prompt, and I'm going to show you this as we go. I'm going to do extend. Now, I'd already put data on these disks, so the reason I did that is to demonstrate here that I can extend these online while we're running. So now I'm going to pull up my computer again, and I'm going to look at this volume, and it's gone up to 6 gig from 1 gig. However, the data is still there. Everything's fine, everything's intact, no check disk, everything's great. And this one, also 6 gig. I'm still snowmobiling. Okay. And then finally, I don't want everybody looking at my picture, so I'm going to just delete my partitions. And then go back to RAW. So it's a really good tool for managing the storage configuration online, extending volumes. Basic, you can convert basic, dynamic. There's a lot of features. Feel free to go in and look at the online help. It's very nice for scripting. All right, now let's see if I'm smart enough to put this thing back. There we go. Okay, now I'd like to introduce Svetlana from the cluster team, who's going to finish up a few slides for you.
Hey folks, can you hear me on the back there? Okay, cool. I'm a program manager in the cluster team, and I will give you... Okay, sure. I will give you a brief overview of the new features we put in the cluster service in the .NET server and how it applies to the file service. There are several techniques that you can use to make your file service highly available. The first one is using DFS with replicated root and content, and the second technique is using failover clustering. And some of you may be using that already, and I will talk about the failover clustering in this session. Failover clustering may be used to failover or make highly available simple file shares, DFS roots and file shares, and replicated DFS roots with file shares. And several ways to make the data available, I'm sure you're all familiar with, are multiple paths to data, redundant storage controllers, and using different RAID levels. So we've been pretty busy in this adding features to the cluster service in the .NET server, and I will just give you an overview of a few of them. And we do have a white paper available that lists all the features that we put in the .NET server clusters. The first and probably the biggest feature that we've added is the simplified the cluster configuration wizard that greatly simplifies configuring and installing clusters. It's a multi-step wizard. It's a UA, graphical user interface tool, and we also have command line tools that you can use to script setting up clusters. We've added Active Directory integration, which enables the end-to-end Kerberos authentication. We are supporting larger clusters in this version. We can support up to 4 nodes in the in the enterprise server version, and up to 8 nodes in data center. We've been working with the file system team to put in support for clustered nodes for some of the features that Steve was talking about, and the ASR, automatic server recovery, can be used now to restore clustered nodes, and either the entire cluster or just one node of a cluster. We support rolling upgrades from Windows NT 4 to Windows 2000 and from Windows 2000 to Windows.NET. Rolling upgrades mean that you don't need to bring down your entire cluster. You can do one node at a time while the other node is running and keeping your application available to clients. We've also added WMI support. If you guys are using clusters, you remember or you know the pains of changing passwords on Windows 2000 clusters. So we've put a lot of work to make it simpler and easier. You don't have to bring your cluster down to change passwords. So that's a really good feature. We've improved SAN support in .NET Server, And we've added a whole list of file system enhancements. We're supporting the online extended basic disk online that Steve was talking about. We support mount points that allow you to use more than 23 disks, client-side caching, and multiple DFS routes in the cluster, as I mentioned before. And like I said, there is a white paper available that if you'd like to take a look at the entire list of new features we added in clusters, please let us know and we'll give you that white paper. And here are the configurations that we support in .NET clusters. We still support 2 nodes SCSI clusters in the enterprise server version. We support up to 4 nodes fiber channel clusters with the enterprise version, and up to 8 nodes data center. And all these configurations are available on the 64-bit platform as well. That's it.
Okay, so I'd like to open up the floor for any questions that you may have. I'll open the floor for any questions. Well, lots of questions. Okay, let's start over here.
The shadow copy, when you do your snapshot, you handle like the mount point.
Okay, so the question is, when you're doing a shadow copy, how do you handle mount points? That's an excellent question. It's very good. The shadow copy, if the backup application that's creating the shadow copy has to go through and enumerate to understand if the volumes are mount points, and he has to actually include both of those within the shadow copy from a backup standpoint. When you do the backup, if you go to the shadow copy today and you try to traverse a mount point, it doesn't work. But when you restore it, it does, because the mount point is pointing to a volume that's pointing back to an original volume. So from a backup standpoint, today it isn't an issue. The third parties understand that mount points have to be enumerated and included in a snapshot, and following that, after you do the restore, it works. Okay. I'm going to kind of work this way. I'm not ignoring you guys.
What's the alias to get the white paper?
What's the alias to get the white paper? It will be posted on the Microsoft Outside Library website when it's completed. If you have particular interest in it, leave me your card, and I'll make sure that you have an opportunity to look at it and you get it.
As part of expand, are you able to expand the volume if you're using it?
Okay, so the question is on disk part, are you able to expand the volume of the system or boot partition? I don't know. David? I think you probably can't, but I can't remember for sure. So if you leave your card, I'll answer you for sure. If you leave a card up here with me, I'll write the question on and get back with you. Okay. Yes.
Can you shrink a volume?
No. Yeah, the question is, can you shrink a volume? The answer is no. We've put the shrink into the interfaces, but at this point in time, it is not supported. It's not implemented. It is a feature that may be added at some point in the future, but at this point in .NET, it will not be added. Okay, over here.
Could you clarify how often you will be updating ASR.SIP? Is it being done in coordination with another process?
Okay, so the question is how often you update ASR.SIF. Is it done in coordination with another process? Yes, it's done in coordination with another process. The process is the backup application. In the box, that's NT backup, but third parties have the ability to create it. When you create an ASR backup, the SIF file is created at the end of the backup session. So it creates the files and puts them in the repair directory and also puts them on to a floppy at that time. So if you lose your floppy, you can actually get the files back. We also partition when we do the backup, this is NT backup only, we create a very small partition with those files in it. So that if in the case that your system goes down and you say, where's my floppy? You could take that tape to another system, restore the first tiny partition of the 2 files, write it to a floppy, and put it back. But the answer is, the file is created at the instance of backup. because the backup has to match the SIF information. They go as a pair. Okay, so we have questions over here. Yes, sir.
Some of the storage vendors like EMC, they're coming with something that's called diskless server. I don't know if you're familiar with that term. And what is Microsoft's plan? Is it, do they support it? Do they?
Okay, so the question is, some companies like EMC have a diskless server. I'm familiar with diskless server from the old Unix days. We had lots of diskless server. I'm not familiar with the exact implementation. Boot from SAN.
EMC pleads innocent. We just supply the disk.
We are working to accomplish. I'm sorry? Great. So there's a session tomorrow morning on this, and I don't have to answer the question. Okay, I know there's some more. Yes, sir.
You mentioned in a previous slide that some applications and services will integrate with the volume shadow copy. And what about existing applications like Exchange 5.5 or Exchange 2000? Will they have to be retrofitted to work with this, or is this only for future application support going forward?
Okay, so the question is, I mentioned in my earlier slides about writers, and the question is, are writers going to be retrofitted into products like Exchange 5.5 or other products that exist today? The answer is no. They will not be retrofitted. As far as I know, all the plans, Exchange is working on a writer, the functionality of a writer, and they have plans for its release. But at this time, I don't know of any teams that are planning to retrofit back. Furthermore, we're not planning to retrofit the shadow copy infrastructure back to prior releases at this time. So the major Microsoft app, and we're working with other major applications within the industry to provide the writer capability, but it's all planned for future releases. Yes, sir.
Is there a paper on VDS and FVS?
There are papers on VDS and FVS. There's nothing really on FVS. It's not really a feature of this of .NET Server, but they're only available under NDA at this time. My guess is that you'll have, you'll of course have user documentation when it comes out, and there's going to be lots of information in Resource Kit. There may be white papers available when we get closer to a release date. Yes, sir.
When you create a shadow copy, how would you mount it up so that you could access the read-only copy?
Okay, so the question is, when you create a shadow copy, how do you mount it? Generally speaking, the shadow copies by default are read-only and they don't mount, because if you're doing a backup, you don't want a user to see suddenly, oh my God, here comes an X and a Y, and I didn't know where that came from. However, you can mount it. There's DOS commands that will mount it. DOS dev is one. You can mount it through APIs. If you're using it in an application, you can actually expose it through APIs. We have an API called expose that will expose it, and you can assign it a drive letter. But generally speaking, that's not a function that we see that's going to happen frequently. If you do VSS admin, you can create a snapshot. There's a VSS admin create snapshot as a command to create a snapshot, and that works in your beta 3 copy today. And then you can use DOS dev to assign a drive letter and look at it and browse it if you want.
Some applications that you could acquiesce, or you could make the file that the application will access from the system. Perhaps you run that procedure and then mount it up and then drag those files off the server. That's my thought.
There's no reason why you can't do that. And you can mount it all through command line utilities. I think you can do everything you want through command line utilities. You can mount a drive, and you can browse the drive, you can look at the drive, you can copy data from the drive, you can copy paste. It's effectively just another drive. So there are command line utilities that do all of that. Yes, sir.
In regards to that question, and
Yes. It's effectively an exact copy of the disk. So all of the ACLs are in place. They all stick. All the security is still there. That would have been a security problem if we didn't think that one through. Yes. Yes, sir.
Can you tell us which vendors are providing this rate?
The question is, can I tell you which vendors are working with us? I don't think so. It's all under NDA, and I don't know if those vendors want their products discussed in this forum, and I'm not the right guy to discuss it. So I guess we could suffice it to say that most of the major vendors are working with us. I'm sorry? We do have APIs for the vendors, the provider APIs, and they are available today under NDA, and that's how the vendors are working with us. We don't see that's a lower level API, and we don't see that as something users would want to do. It's really targeted for storage vendors. Yes, sir.
Even the creation of an XR file, you redirect the output to some network drive somewhere, and then create a boot disk later on.
Okay, so the question is, during the ASR process, can you redirect the output to a network drive somewhere and then create a boot file later? And the answer is no, you can't redirect it. However, we put the files into System 32 repair, or the Windows root directory repair, not System 32, but repair. We drop the files into the repair directory, and you can copy them or recreate. It's 2 floppies. There's nothing or 2 files on the floppy. There's nothing formatted about the floppy. It's a standard, fat floppy with those 2 files on it. And so, yes, you can move it on a network. You could copy it, or you could write a script that after the backup is done, you move those to a network share under a machine name. And it's very easy to recreate floppies. And also, additionally, like I say, in NT backup, we actually create a separate backup on the beginning with those 2 files in it that you can restore those 2 files to a floppy or restore it to a disk and copy it to the floppy in case you lost your floppy. So the answer is yes in both cases. All right, any other questions? Yes, sir.
You talked about data framing, but you didn't go into a whole lot of detail. Is this going to come back?
No, the data freighting scenarios, I did touch on it a little bit. If you have a hardware solution, in other words, if you have some kind of a third-party storage box that has the ability to create hardware plexes, then you can control the SAN such that your snapshot actually is transported to another machine. And then you can mount that on the machine for the purposes of backup. If you wanted to have a backup server, you could create a snapshot and then unmask that, rezone, and have that appear to another machine. From that machine, you could do the backup of the data directly. Additionally, if that happened to be your SQL server, you could start another instance of SQL on that machine, mount the database, and go about and do queries. So, for instance, if you were at the end of the quarter and you needed to get your data at the end of the quarter, as opposed to doing the as of type query in SQL, which are very time consuming because they have to roll the transactions back to find out what it was as of that time, you could create a snapshot, and then you could do all of your data mining for the end of quarter reports from the snapshot. And when you're finished, delete the snapshot and continue. That's the data freighting scenario that we're talking about. Okay, last chance for last questions. Anybody? All right, thank you very much for coming.